In this video we have the integral of e to the x over the square root of 1 minus e to the 2x dx. And this will be another u substitution. You can pause the video and try it. So I'm going to rewrite this way. So I've got e to the x dx and in the denominator, the radicand here, I'm going to write that as 1 minus e to the x. Then I'm going to square it. And I do that because I know the square root, the derivative of e to the x is e to the x, and I have an e to the x in the numerator. So I'm going to do this. I'm going to let u equal to e to the x. Then du will equal to e to the x dx. And then we just make the substitution. So I'm just going to look at it this way. E to the x dx is there. And the numerator I have e to the x dx. This is together here. So I can replace e to the x dx in the numerator by du. So this becomes u, or du I should say, here. And the denominator then will be the square root of 1 minus e to the x is u, so we replace that by u, and then I have a square. And then there is a formula for the integral of du over the square root of, the formula is written a squared minus u squared. But isn't that form? Because 1 squared is 1, and of course I have u squared right there. So the formula says if you have it in that form, that should be the integral of this expression that looks like that should be the sine inverse of u over a. In this case, obviously I have u there, and then a squared would be 1 squared, so a would be 1, so it's u over 1 is u plus the constant of integration. Then you just go back to the original variable. So this means that sine, and that I could call that arc sine, another name for it, this sine inverse of u, but u is e to the x. So I got sine inverse of e to the x plus a constant of integration. So some instructors will tell you what formulas are given that you can use on a given exercise. So you should be aware of that. I know when I took my first integration tests in college, the instructor gave us I think it was a 3x5 card or something like that. And we could write as many formulas on there as we wanted to. So obviously we wrote as small as possible to get as many formulas in there. But at the same time, you can derive some formulas. Let's go ahead and derive this formula here, just for the heck of it. The video is over here. This is it. This is the answer. So the rest of it is just a bonus. But I'm going to derive this formula right here to show why this is true here. And I'm going to use a trig substitution here, and I'm going to say let sine theta, and I'm going to have my triangle here, right triangle, and this will be theta, then this will be u. Sine of theta is u over 1 then, And then this side would be the square root of 1 minus u squared. You know that can be verified by the Pythagorean theorem. U squared plus radical 1 minus u squared is equal to 1. So I'm going to say sine theta is equal to u over 1, which of course is u. And then the radical in the denominator is going to be 1 minus u squared, but u is sine theta, so that would be sine squared theta. But we know from trigonometry, basic identity, we know cosine squared plus sine squared is equal to 1. So if I take the sine squared to the other side, that gives me cosine squared. So this is actually the square root cosine squared theta, which is equal to cosine theta. And then take the sine theta equal to u, take the derivative of that, that'll give me cosine theta d theta, and that equals to du. Okay, so there's the answer to this particular problem. I'm just giving you a little bonus here, so I'm just deriving this formula just in case you haven't seen it. And I could derive the formula more generally here and make this instead of a 1a squared, but just so it fits this problem, I'll leave it like that. So then just take it from here then. Let's assume we didn't know that integral there. Then from here we know that du is cosine theta d theta. So this is cosine theta d theta. And that's over the integral, and the denominator is cosine theta. That's cosine theta. So this cancels out, this cancels out. So all I'm left with is a 1, you can call that a 1 d theta, and the integral of that would be theta, integrating with respect to theta, plus your constant of integration. And then we come back over here to this formula here. We have sine theta is equal to u. So taking the sine inverse of both sides here, this would tell me that theta should equal to sine inverse of u. But u is e to the x. So this can be replaced by then sine inverse of e to the x plus a constant of integration. Thanks for watching. We'll see you next time.